Today we are going to talk about fluid mechanics, and I think it is very quite interesting topic and very important too. Okay, so what is a fluid mechanics? Fluid mechanics. Inside of fluid mechanics, we study three different topics, such as fluid statics, the behavior of fluid when it is at rest, fluid kinematics, the velocity and accelerations of the fluid, and as well as fluid dynamics. There are three different topics, which is of course the effect of force and accelerations due to force of fluid, of course. Let's start from the very beginning. What is fluid and solid? And solid. Sorry. Okay. So a fluid is a substance, a state of matter, where it deforms continuously on shear forces. But solid doesn't deform continuously. It deforms, but it doesn't deform continuously. Okay. In fluid, we have our stress is directly proportional to strain rate, the rate of strain. Okay. Uh, Water solid have elasticity, and hence it exhibit springiness. The springiness is the quality of solid due to elasticity, whereas fluid doesn't has that kind of springiness, so it is said to exhibit zero memory. Also, fluid has zero compressibility. Stability. That is, its bulk modulus is zero. If we create a curve or graphical representation of stress and strain at zero stress, we have the continuous deformation, which state is known as fluid. This is known as ideal fluid. But ideal solid should be, it should bear any stress and should not produce the strain. So it is ideal solid. Okay. There is a substance known as asphalt, which is a solid in initial shear. Initial shear. It means it behaviors like this for initial shear stress. From a particular shear, it flows. It acts as a liquid. Okay, acts as a liquid after uh, application of shear. So it should be like this. Okay, it could be Newtonian or non-Newtonian. We will talk about that in later. Now we have known about fluid and solid. We will talk about the continuum properties of the solid. Sorry, continuum property of the liquid. Continuum. Continuum. So what is a continuum? We know that in a molecular state of the liquid, there is a huge distance between atoms. Yeah. So the property of this atom and this atom uh, could be different or could be same, but we take properties considering fluid as a continuum medium, meaning that the properties of fluid, such as temperature. So since there is no any element between these two atoms, so it doesn't have it should not have the temperature of fluid, but we consider this as a continuum medium, so it is a very continuous medium, so there are no any gaps. So the properties of the fluid in a liquid always vary with respect to space and time. It means if you go in a bucket of water, if you go from this point to this point or this point to this point in time or and space, through time, the properties vary of a fluid. So what are the properties? The density, temperature, velocity of flowing fluid. So these are all the continuum medium. Here the properties is limit dv dv dot and dm by dv. So it represents the continuum or behavior of the fluid. There is a no slip condition, which is the nature of the flow over when a fluid flows over a stationary surface. Stationary surface, then there occurs, we see like this is a stationary plate, and a fluid is flowing over it. Then the nature of the flow, at the point where the fluid touches the surface, it shows that the velocity of the surface will be zero. Sorry, velocity of the fluid at the surface. Velocity of fluid at surface equals to zero. So this is the nature of the fluid flow at stationary surface. So this is known as no slip condition. So this leads to development of velocity profile. For example, if I want to make a velocity profile of this diagram, so this is the surface. Velocity at this point is suppose 5 meter per second, and then this point is zero. So it has to be developed like this. So this is 5 meter per second velocity. This length represents the magnitude of the velocity, but here it is zero. So this is due to the nature of the flow at stationary surface. So this is known as no slip condition. Okay, we have a Lagrangian and Eulerian approach of analyzing fluid flow. And analyzing, since we have known that the fluid properties, fluid flow is estimated by using fluid properties. So there are two approaches: Lagrangian, sorry, Lagrangian and Eulerian. Eulerian. So what is a Lagrangian approach? So we have to track a particle of fluid, and we have to see the change in properties of that particle. Change in properties, or simply track the properties of that fluid particle. That fluid particle. So it is difficult for practical flow, as we know that the individual particle tracing in fluid is very difficult. So it is very difficult for the practical flow. Practical flow application. But we can use spray, and we can use different other particles, and we can track those particles instead. Whereas in Euclidean approach, we have a control volume. So before going into Euclidean approach, we should study about, if this is a pipe flow, and this pipe has diversion. like this. If I want to track a property of this particle flowing through this, I'll connect this to this particle. This particle supposedly goes in this direction. So I track the property of the particle in each point in space and time. So this is Lagrangian approach. But what if I use a imaginary boundary known as bound control surface? I use this surface as a control surface. This is a imaginary, not a real control surface. So sorry, we have our system, we have our surrounding, and we have our boundary. This boundary is known as control surface, and this could be imaginary or real. But the point here is that we trace the particle, we trace the properties or field variable in this control volume. Field variable, what are the field variables such as pressure field in this particular control volume, or simply temperature field, and we observe the properties of the fluid through this control volume approach. Either we can do one particle at a time, or we can do a control volume, which is a of course system having a control surface. So this approach of analyzing fluid flow is known as, sorry, Eulerian approach. Control volume. So we have flow in and we have flow out. This is our flow in and this is our flow out. Flow in and flow out. And we are uh, evaluating field variables. So what are field variables? Pressure field, which are the space function of space and time, x, y, z, t, or temperature field, x, y, z, t, or simply variables. Velocity, such as x, y, z, t. These are our field variables, which we will trace in control volume, and they are the function of space and time. So these are two approaches of analyzing the property of the fluid, or simply analyzing the behavior of the fluid. We will talk about control mass. Yeah. So we have known about the control volume, but there is a concept of control mass where we have our such as our piston and cylinder. This is our cylinder and piston arrangement. So here, no mass transfer in control mass. There are no mass transfer, but we have our energy transfer. This kind of control system is known as control mass system. Okay. So now we will talk about Tithi. This is it.